Good morning. This is Raghunath from Department of Mechanical Engineering. I welcome you all to this thermal engineering laboratory. Today we will going to discuss about. Today we will going to conduct an experiment on refrigeration. So we all know what is meant by refrigeration. Refrigeration is the science of producing or maintaining the temperature below that of surrounding temperature. Okay, so the refrigeration is basically follow the physics, which is on sensible heat and latent heat. We know sensible heat only there will be a change in temperature, no change in phase. But in the latent heat, there is no change in its temperature, but there will be a change in its phase, right? So the law which is applied on the refrigerator and air conditioning is second law of thermodynamics, which is gaseous statement. Okay, so the refrigerator actually consisting of the four major equipments, which are all condenser and then expansion device, evaporator and then compressor. Okay, so this will be divided into two sides. One is a high pressure side and another one is a low pressure side. Now we can see in our refrigerator. So this is a compressor, this is a condenser, and this is an expansion valve, and this is an evaporator. Okay, so you can see here the evaporator coil is submerged in the liquid. Okay, so actually what will happen, these compressor, condenser, evaporator, all these four major equipments are connected through the tubes. Okay, so what will happen, the refrigerant which is inside this tube will flow in the all equipments. Okay, so in our fridge, the refrigerant which is in the evaporator is in low temperature and then low pressure fluid. While switch on the refrigerator, the low pressure, low temperature refrigerant will flow to the compressor. Due to this high compression, the pressure and temperature of an refrigerant will be increased. Then it flows through the condenser, where it loses its latent heat. Okay, so the heat transfer will be takes place here without changing its pressure and temperature. Then this high energy fluid flows through this expansion device, where it loses its pressure and it loses its pressure without changing its energy. Then it flows through the evaporator. This liquid flows through the evaporator. In evaporator, it absorbing the heat from this liquid. Okay, in our fridge, the inside the vegetables, okay, the heat will be absorbed by the refrigerant. Then this refrigerant is changing its phase from liquid to vapor. Then it flows to the compressor. This is how this cycle is repeats. So for this experiment, we need to take a condenser pressure and evaporator pressure, both inlet and outlet. Condenser inlet pressure, condenser outlet pressure. Likewise, evaporator inlet pressure and then evaporator outlet pressure. Also we need to take evaporator inlet temperature, outlet temperature, condenser inlet temperature and outlet temperature. After taking these values, with the help of the pH chart, we can calculate the theoretical COP, which is a coefficient of performance. Okay, with the help of pH chart, we can take enthalpy at 1, 2, 3 and 4. Okay, so the basic readings we will going to take here is evaporator's outlet pressure and then evaporator's inlet pressure. So if you see here, the low pressure side, which I have said earlier, the low pressure side having evaporator and expansion device. So the pressure here, these two are evaporators inlet and outlet pressure. So the evaporator inlet pressure is about 30 psi. Here also it reads about 30 to 35 psi. Right? Here 30, 32, here 30, here 35. Okay. So Then this condenser pressure is about 150 psi. Here also 150 psi. Okay, so constant pressure heat rejection takes place from condenser and evaporator. Okay, the evaporator also reads same pressure, and then condenser also, in both inlet and outlet, it reads same pressure and temperature. After that, we need to take an evaporator's inlet temperature. Okay, so the evaporator inlet temperature is about 10-11 degrees Celsius. Evaporator outlet temperature is about 10 degrees Celsius. This 10 degrees Celsius vapor enters to the refrigerator. After getting out from the compressor, here you can see the temperature of the refrigerant will be 40, 45, about 50 degrees Celsius. You can see how this temperature is increased. It's 50 degrees Celsius. Then it enters to the condenser, where it loses its latent heat, okay, without changing its temperature and pressure. But in the case of actual, there will be a decrease in temperature. Here you can see the temperature is about 39 degrees Celsius. Then it enters to the expansion valve. Right, after the expansion happen, the pressure also reduces, temperature also reduces. Okay, so the temperature will be very low. Okay, this is how refrigeration testing is works. Then for actual COP, we need to take a energy meter reading and voltmeter reading, ammeter reading. So we have to take an energy meter reading for 15 revolutions. So here the energy meter disc is running here. We need to take from this black dot to 15 revolutions. We need to take an energy meter reading. Then we can take voltmeter and ammeter reading. After substituting these all the values and quantity of water in the evaporator tank, okay, then that evaporator's initial temperature is already noted about 27 degrees Celsius. Okay, now we can check that evaporator's temperature. Here you can see how this temperature is decreased only 5 degrees Celsius. Okay, so initially the temperature is around 22 degrees Celsius. After running an experiment for about 30 minutes, the temperature is about 5 degrees Celsius, the evaporator final temperature. If we put these values in the tabulation, after that, if we put these values in this formula, that heat extracted MCP T2 minus T1, T1 is 22 and T2 is 5 degrees Celsius, we can get how much amount of heat is rejected from the system. Then for work input, we need to take a number of revolutions and then time taken for this revolutions. After putting that energy meter constant, we can find out the work input. If we do the COP for this, we can get an actual COP. With the help of refrigerant chart, we can find out theoretical COP from pH chart. Okay, so the refrigerant table will provide this value for this pH chart. So we need to take a R12 refrigerant chart for taking the values. Okay, the refrigerant which is flowing is R12. Okay, we need to take a R12 chart for calculating the pH values. Okay, thank you.